The agenda for today, a little bit of introduction. Being an ex-college professor also, I always like to define some things, and we'll hit some of the concepts at a fairly high level, things like risk-based testing and exploratory, and a little bit on some of these attacks that are in my book, as well as a view, and I know Jean Ann talked about this a little bit, but the kind of skills that we hope testers are out there working on to get better on. Go ahead, next slide. There'll be delays here, so ask everybody to bear with me. I hope Amy updates. Okay, so just to make sure we're all on the same page, because I think a lot of times when we say mobile, people immediately think of smart devices, smartphones, and things like that. And that's certainly the biggest interest area right at the moment in terms of the market. Android, iPhone, those kinds of things, tablet devices. But in the grander scheme of things, when I talk to students and have people and things that are in my book, mobile is more than just smartphone. It now includes medical devices, and they're starting to interface smartphones with medical devices. It can include car information systems, and these systems typically have the same kinds of problems we see in the embedded world, but they also have some things that the embedded world doesn't have. Areas to worry about are things like the amount of power that you're using, batteries. Memory tends to be limited on these things. Harder to expand than, say, your PC. And we cram lots of apps in these things, lots and lots of little apps. And so while this is a hot area and the rules for how we develop them and test them are changing, I think there's some lessons learned that we can bring from the classic embedded world forward into this world. Go ahead, next slide now. And I'm always a big believer in learning from the history of other systems, IT systems, and the close cousin here of the mobile smartphone world is the embedded world. And so when I started my research into this, I came out of the embedded software world and started testing mobile and smartphone kinds of devices and realized, gee, there's a lot of synergy here. And the classic embedded world, we're usually controlling some kind of specialized hardware, as opposed to the IT world where it's kind of a generic set of hardware, the PC platform as an example, and we're maybe controlling a few devices, but not controlling, say, something like the rocket, the world I came out of, or controlling things inside of a car. These are embedded software systems now. The typical car these days has between 15 and 20 processors in it. This world is very subject to things like noise, power issues, timing, sensors, initialization. When I did my research, I saw bug commonality in all these areas. Again, the embedded world, sort of like the mobile world, has resource constraints. The amount of memory, processor speed, time can be a big factor. Once upon a time in the embedded world, we really didn't think about the human-computer interface, but now more and more embedded systems have human interfaces, and certainly you go into the mobile smartphone world, we have in the smartphone a very robust graphical interface. But if you think about that graphical interface, it's different in terms of the amount of real estate than your typical computer screen and a PC. So that enters into a resource issue that both developers and the testers need to think about. And finally, in the embedded world, a lot of these embedded systems are controlling something. Maybe controlling a car, maybe controlling a factory. there are hazard and safety issues associated with these things. And interestingly, and you can move to the next slide, Amy, in the mobile world, we're seeing more and more interest in the mobile and the smartphone world to putting these devices, controlling things. I know some people working with the medical industry to have an interface between the smartphone, a Bluetooth capable sensor that's monitoring things like heart rates on patients. That's kind of a blending of worlds now that I think we as testers need to think about. And I'm hoping the screen updates. It seemed to partially update here. Maybe if I give it a second.
It's updated here, John. I think so, I have less delay here.
Pardon me?
I think there's less delay on my side here.
It may be because
your location.
Okay, maybe because I'm talking. Maybe because I'm talking, it slows down the whole network. Examples of these kinds of things. Of course, you see the smartphone on the one side there. Cars, airplanes. I couldn't find a picture of a light switch, but light switches now have smartness built into them. Certainly in the medical world, pacemakers, dispensers. I talked with some doctors and things like that, and one of them had to recall their patients to update the software in their pacemakers in their chest because there was a software bug. Kind of scared me. I'm not sure about the patients, but so we're putting software in everything, basically. It seems like if it's an electronic, they put software in it now. Certainly the smartphone world is big. Go ahead to the next slide. And so that kind of sets the stage in terms of definitions for these things. The chart that's coming up here is something that both Jean Ann and I use. We've done some tutorials together and things like that, and I kind of like this chart. I know she used it too. And in the mobile embedded app world, we have kind of three basic categorization of software programs. You have the native apps that run, say, on the smartphone or run on the embedded device. They're wholly contained in there. They're maybe not overly reliant or not reliant at all on a network connection, and they run just fine essentially in a standalone mode. If you think about your car, its anti-lock braking system works just fine when you're not connected to the network. Some native apps on smartphones the same way. The other side there of that picture are the web apps. And these are the apps that are on our smartphone, maybe even other kinds of systems, where to have the thing work, you have to be connected out to the web, to a server. The app is very reliant on the server to provide information and feed things back. And if the network connection's not there, things don't work very well. Then there's the hybrid apps. And my take right at the moment is a lot of, particularly the smartphone world and some of the embedded space, are moving more to the hybrid approach, where they have some of the nice features of the native apps so that you don't have to be connected all the time. They can offer functionality and features when the connection's not there, and sometimes the connections on the cell phones drop. And then when the connection's there, information's exchanged, and so they have some of the features of the web app. And I think the hybrid apps have some definite advantages of not having that dependency on a network connection. You can move ahead here. So that kind of sets the stage for, how do we test these things becomes an issue. And being a systems engineer once upon a time, and you'll have to click ahead in a series of clicks here, Amy, by the way, we start thinking about the hardware, where things run. And that's the first starting point. As I said, most software testers just accept the hardware in the PC world kind of as it is. And in our testing activities, we start with stimulation inputs into the software, but it's running on hardware. And we get some, keep clicking, Mimi, it builds itself as it goes along. And we get some kind of output. And this is what the customers pay for, expected inputs, wanted outputs. It gives you information on your cell phone. The problem comes when you have some kind of unexpected input or a bug in the software, and you get unwanted outputs. This is what the testers are trying to find, is the unwanted outputs. Find those bugs. Yes, we have to test for the wanted inputs, make sure the system's working, meeting requirements, those kinds of things. But if we just stop at showing the wanted outputs are met, we won't find as many of the bugs as we could. And I'm very much the kind of person who wants to provide as much information to the team as possible about unexpected, unwanted outputs. Unwanted outputs, besides being the classic display is wrong, there can be things like timing performance isn't that great. I know from using my smartphone a fair amount, sometimes it seems to run really slow. My wife and I have the same smartphone. She's got a bunch more apps on her phone than I do on mine. Sometimes her phone just does not run as fast as mine. That's the kind of thing that maybe the developers and the stakeholders want to know. So here's my starting point picture for how I think about the testing. Inputs, how do I create unexpected inputs to the hardware and the software? And yeah, I'm wanting to see that I get those wanted outputs, but I really want to try and find those bugs and recognize them. You can move ahead. And so what I'm going to be talking about and what the book largely talks about, not exclusively, is how do we go about finding the bugs and find them before the customers and users do. So I start here and say, gee, a lot of the patterns in programming errors are the same between the IT world, the PC world, the classic computer world, and the mobile and embedded world. So we can apply some of the same test techniques, some of the activities James Whitaker talks about in his books on attack-based testing. You can apply those in the mobile embedded space. They work. But for me, more interestingly, and what I like to focus on are what are the differences in mobility? What are the differences in the error patterns? What are the differences from moving things around? And so I kind of divide things into mobile embedded error patterns. We'll talk about that. The mobility of the system itself, an example there is the network connections. And then the resources, things that are different in how we put these systems together. You can move to the next chart now, Amy. And so one of the things that's different in the embedded space and a little bit the mobile space is the life cycle, how the system gets created. And so I show that here. We see the system creation going on. There kind of in the middle part, we're building some hardware. Hardware is being updated, changed. New products are coming out. It seems like iPhone and Android, every 3 months to 6 months, they have a brand new platform. I don't know how many platforms there are now. I saw an interesting paper on that not too long ago on how many different kinds of platforms and operating systems level in the smartphone and embedded space. It's just huge numbers. So we have this hardware going on while the software is getting created. So you have a series of software builds. You see stair stepping down there. And it's not intended to indicate a waterfall because we may actually field some of these builds out into the user community as we go along. And these can be done now in literally hours in some of the app world. or days, and sometimes longer, months, but it seems like a lot of the, particularly app world, very short cycles. And then in the middle of that, you get a hardware change. Something doesn't work in the hardware, a feature introduced by a hardware vendor isn't there or is different than expected, and as a result, we have to do a fast build, and the software may be late. And then as testers, we get crunched, and this crunch happens over and over. So I'm a big advocate for testers, not at the end of testing, but throughout the testing, throughout the builds on things, and that's how I like to see things. Go ahead to the next chart. So that affects the testing that we do, and this notion of providing information and the attack-based testing that I'm advocating, in addition to the other techniques that are out there. So I built this concept of the mobile embedded attacks based upon common error patterns. I've published some papers on an error taxonomy. It's industry-based, where I looked across the embedded space, I looked across the mobile space. I'm constantly reading on errors that escape out into the field and make the news media, either front page news in a few cases, or sometimes just the trade publications. And you look at that kind of the mobile handheld embedded space, and you see problems and requirements of design, logic, control, data, initialization, interfaces, security, and gaming, which is common to the IT, PC world. We see those things also. So could be argued, gee, it's not that different, but you look on the right side there, and we do see this problem, particularly on the embedded side, of these hardware development cycles going on at the same time with software, and you get some unknowns because of that. We have the limited resources, and in the resources there I'm referring to including things like screen size. I've seen a few apps on smartphones where they obviously just took a web page and tried to crunch it down into a very small screen. You can't see it, or if you can and you blow it up, it's very unusable. You have unique problems in the sensor world, where you have sensors embedded in smartphones, by the way, embedded in many of these embedded devices, and it's specialized for a particular task. It's unique to that problem being solved. We see problems in that area of controls and interfaces. The other interesting thing that I've seen quite a bit, again maybe a little bit more in the embedded space, but I am seeing it a little bit sometimes as we build Bluetooth devices to interface with the phone. A common thing that I see is you have the hardware gets built, they find a problem in the hardware, and then they say, gee, let's just leave the hardware alone and we'll figure out how to fix it in software very late in the cycle. So all of a sudden the software guys are scrambling, the test people are scrambling. And that can be a very interesting exercise because management expects the thing to be delivered to the original schedule, and yet you've got all this new functionality that you're having to build and then test. And then another one that I see quite a bit is the world of timing. We're all probably familiar with the concept of timing from the aspect of performance, load and stress testing, say on like a website. But then you have some of these devices where there's timing interfaces, maybe between a Bluetooth device and the smartphone, and you have other apps running in the smartphone and things coming in from a phone call and maybe a message, and all of a sudden the performance takes a hit. So testers now have to think about a different set of performance issues than just the classic load testing. Go ahead, Amy. So as I saw these bug patterns and I saw these problems, I started saying, gee, what is a tester interested in kind of exploring the risks, finding the risks, could I go and do on that? And that led me to the concept of TAC-based testing. In the mobile world, by the way, we have the mobility itself. We have environmental issues, such things as noise, weather, heat and cold. I live in the western United States, in the mountains of Colorado. It gets very cold. My smartphone acts differently when it's very cold. Network connections can cause things to be different in mobility. Most of you probably experienced a smartphone having real nice 4 bars connection and all of a sudden dropping down to 2, and you were standing still. Well, they can do things with the cell towers that change the focus of where the beams are going, and suddenly you may drop connection. That can affect your apps running. And a big one that I think a lot of people forget in the mobility world is that of batteries and how you deal with batteries, heat, charging, duration, and that's a big aspect of the mobility. The outputs, these devices are very susceptible to electronics and electronic noises. It's interesting, in the United States, the FAA is changing the rules on how smartphones can be used during takeoff and landing. However, they still are not going to allow them to be used in broadcast mode. Why? Because there's some indication that it will interfere between the smartphone, cell phone, and the electronics of the airplane, which during takeoff and landing would probably be bad. Mentioned earlier, smartphones have errors in the inputs, the sensors, those kinds of things. Smartphones and the apps now have a huge complexity problem. I've heard numbers on both Android and iPhone of between 8 and 12 million lines of code. If you add up all the apps and things that people put on there and the operating systems, just huge amounts of complexity. That can all interact with each other and cause strangenesses in how the software you're interested in testing works about. And then finally, as I think I already mentioned, and you can move ahead to Amy, screen size, memory, and CPU speed. Yeah, these devices are fast, but they're not as fast as a PC, and it's certainly not as easy to upgrade memory. And I'm waiting for my screen to replace. So I'm a big supporter of the idea of risks and risk-based testing. And here in this little short webinar, I can't go into everything here. This is a slide Jean Ann helped me put together out of some information that I have on things we both work together. And risks are important because we can't test everything. Testing is an intractable problem. So we start thinking about what things should we test first, what things are most important. And here we see some broad classifications of those things that testers in their planning and thinking about how to do their testing of mobile and embedded devices need to think about. Such things at the top level there are their business risks. Are you a brand new product and is time to market the most important thing for you? If the answer is there, yes, you may accept a few risks that you might not accept in other kinds of places. Another case, though, might be I'm dealing with a medical device, say the pacemaker I referred to earlier. There, the product risks are going to be much greater. I might want to delay time to market to do a better job of finding as many errors in that pacemaker. Why? Because a pacemaker can kill somebody. So the nature of how I do my testing changes a little bit of that. All over there on the right-hand side, you have process risks. Such things are you just recently moved to doing an Agile approach, which a lot of us in the mobile app world, we're doing Agile. But a lot of people are new to Agile. It takes a little bit of time, in my experience, doing some Agile coaching to move from, I'll call it, traditional approaches or maybe chaotic approaches to agile, that may introduce risks that testers have to think about. The other aspect of that, as I mentioned just a minute ago on the pacemaker side, if you have regulatory things, the pacemaker is very much regulated in the United States by the Food and Drug Administration. The activities I do in my testing for that is going to be different than, say, a little smartphone game app. Both may be important to management folks, but one's maybe more important than the other in terms of things like regulation. So I like to think risks. I like to do risk-based testing. That drove me into the concepts of exploratory testing. Go ahead, next slide. I'm a big advocate of exploratory testing. I've practiced it for years. I used to have people argue with me that you can't do exploratory testing in some of the mobile environments, say like the medical world, or some of the environments like the space shuttle that I came out of. But I found, in fact, we were doing forms of exploratory testing in both mobile and embedded. And certainly the mobile app world can benefit a lot from exploratory testing. And I say in here, I think you still must test requirements. Don't take me to say that if you've got requirements, not everybody does, by the way, but if you're lucky enough to have requirements, we still need to do verification checking, what Michael Bolton calls checking testing. That's kind of a necessary first step, but it's not sufficient. I don't think you can stop there. Too many testers and too many projects do. So I like to do risk-based exploratory testing to give projects rapid feedback on that different kind of life cycle I showed earlier. Before maybe we even have all the code working, I'm doing some testing in an agile environment to give feedback to the team on that. I learn from my exploratory testing, and I learn quickly on that. I can learn an awful lot from doing some exploratory testing and maybe trying to do that attacking, trying to break things and find the bugs before the software is even done, and certainly before it's shipped to the user community, to drive down some of those risks I was just talking about earlier. I've used it to do independent assessment, where I get called in by a company that's got testers doing things. I can do quick exploratory and say, hey, did you guys see this? Did you know about that? I've done it sometimes to target defects where I know, gee, this is something I need to make sure definitely does not happen. Say, as an example, is there a problem with the login screens? Or when there's other information that the developers may want. I've worked in places where we knew we had performance problems. The developers were always going, gee, did the code I just input into the build, did it negatively affect the overall performance of the system? The test team provided that information back to them. And as I say, test beyond the requirements is where I really like exploratory testing. Next slide.
John, if I may interrupt one bit, what kind of arguments did you use if some of the people are against using exploratory testing techniques? How did you convince them?
Sure. My answer to that is I think, in essence, all testing is exploratory. The specific question would then have to be, you know, why is somebody against it? And an example I might say there is I've had people from the regulatory types of environments, say in the medical side of things, go, well, you don't have good enough visibility into the testing that's going on and what happened, so you don't have repeatability. You can't provide the information back to the regulatory agency of the testing that you did. Well, my answer there is there's nothing in exploratory testing the way I do it that says you can't have enough documentation to keep the regulatory people happy. I've seen that happen. In one case, what we did was we used a capture playback tool, and capture playback has its pluses and its minuses, but in this case it was a plus because we could capture what was going on in the test. That was then the documentation that was provided back to the regulatory agency that says, this is the testing that was done, this is how it can be repeated. That with some of the more classic script-based regulatory testing made them happy. So again, I would say, in that question of, what's the arguments against exploratory testing, I would say it's kind of context dependent, and I gave you one example on that. So there's a lot of information on exploratory and risk-based testing. Again, in a little webinar, I'm not going to be able to cover everything in detail there. It has the advantages of being quick to, I'll say, plan, design, execute, and set up. You don't have to spend long amounts of time setting up the scripts. You can do things like I mentioned with the capture playback to solve some of the questions that you may get on that. There's been a lot of work done by people like Ken Kaner, James Bach, James Whitaker in this exploratory and risk-based testing concepts. Not necessarily do all those authors say things exactly the same way, and ISO 29119, the software testing standard that is just being released here in the last month or two to the world, also talks to risk-based testing and exploratory testing. So if you're interested in more on those kinds of concepts, I would refer you to those authors and that particular standard. And the standard certainly is aimed at more of the, I'll call it, regulatory standards-based community than, say, some of the exploratory concepts that I know James Bach champions. My particular brand is the attack-based exploratory testing, which we'll talk about here in the next few slides. Go ahead, Amy. And so, key message for me here, by the way, is exploratory is different depending upon who you read. There's no one right way to do it, and so I think people can customize things in test exploration depending upon the context that you're in. Am I still online? No.
Yes, you're still here.
Way, but I'm not seeing the...
I have to slide up via tech. Okay.
It's maybe just taking a little bit longer to get to me.
To the mountains.
Well, it's a long ways uphill from Philadelphia.
I got a short question from Danny while we're waiting. He was asking if you had any difficulty finding a capture playback tool that works on a mobile device.
The answer a year or two ago was yes. There's a lot of difficulty on that. Since then, there's been numerous tools coming out that do various kinds of capture playback. On some of the LinkedIn forums, they've been actually talking about that just in the last few weeks, so there's information there. And if people are interested, I've been compiling a list. It'll be up on my website soon, so I guess have Danny send me an email and I'll get him that list that I've been compiling. I'm not sure how good some of them are because some of them are new, and I will, and I don't necessarily say this is the only tool to use, but one I have used is Eggplant. You still there?
Yeah, we're still here.
Okay, so the question of, why attack? I view it as part of an overall approach to testing. You wouldn't just exclusively do attack-based testing, but again, I use it to try and find the problems before the user does. So my research found common modes of failures that made it out into the real world. Interestingly enough, these problems occur constantly, somewhat universally, from developer to developer and manufacturer to manufacturer. The attack-based approach can include some tools. It can include what I like to call the pattern. As in software development, when I use the word pattern, I'm not referring to a specific script or a specific cookbook or kind of code listing, but a basic thing that can be used and then modified to solve a problem in a particular domain. So you can't think of a pattern like a cookbook. It's more like a pattern for maybe making clothes, where you have to cut it and tailor it for what it is you're trying to do. The attacks can also occur at numerous levels. So unlike James Whitaker's work, I include attacks that the developers might be able to do, because in agile environments that I've supported, the developers are doing a lot of testing. So they should be attacking their own code. I also, in attacks, use one or more techniques, classic software techniques, as part of the pattern of the attack. So go ahead, Amy. So I view attacks as kind of an in-between level in the design approach between the techniques and the plan activities. When I'm, I'll say, thinking about doing my testing. And I think the next chart is, and hopefully it's being displayed. So, what is an attack in specific definitions? And some people may see the attack as a negative. By the way, Jan, did it update on your system?
Yeah, it's updated here.
Hello. Okay. Oh, there, you finally got to me. So an attack is based on a common mode of failure seen in the industry over and over. Some people may see it as kind of a negative because it's aimed at particular, I'll call it bugs, particular problems. But being a tester, I kind of see that as the kind of thing that I want. So it's a positive for me. It goes after certain kinds of bugs or certain kinds of information that the team may be interested in, such things as performance, as I mentioned earlier. It does have the techniques and concepts that can be included in it. As I mentioned a minute ago, the patterns, I think, in the attacks have to be modified by the tester for the particular context and software that they have in hand. So it's not a script. It's not something you can pick up without thinking. You've got to think about these things. And my experience is that a lot of testers that I've talked with over the years have these patterns in their heads, what some people call mental models of how software works, how the software fails. And so these patterns were things that they had in their mind. And I think we've all known those kind of testers that could walk in, be given a piece of software, and just inside of a few minutes find issues with it. And I've seen that myself. I've seen that in other testers that I considered really good testers. And I came to realize that they had this mental model and this pattern. So for me, the attack is the beginning attempts to capture that for, I'll call it, people newer to testing or newer to an area of testing, say like mobile and embedded, to start building up their mental models and their skills in testing. Go ahead, Amy. So that's how I kind of view these attacks. The work that James Whitaker did was very insightful on that, and I think helped move a lot of people into having better skills in their testing careers. And for a lot of us, that's what I'm about, is getting better skills. And so the kinds of attacks that Whitaker talked about in his How to Break books, basically software. He's got one on security and web. His first book had 23 attacks in it. I think the other books introduced another 40, 50 attacks on top of that in each one of those domains. And he targeted areas of user interfaces, data and computation, the file system, and then the software input and output, the operating system layers. I started with that work from his books and the taxonomy I did. I ended up with 33 attacks in my book, Software Test Attacks to Break Mobile Embedded Devices, with some 8 sub-attacks underneath some of those. So a little more than 40 attacks. Go ahead, Amy. And in a webinar, I can't get into the details of all these things. I'll give you a little bit of insight into some of them, though, on the upcoming charts. And I expanded, and I talked to James Whitaker a little bit about this. I said, gee, in the Agile world, we're seeing an awful lot of activities on developer testing, the code level things. So I introduced developer attacks. James thought that was nice. He agreed. Control systems, hardware-software interfaces. Again, those are those unique kinds of hardware that the embedded people have. The mobile space in the embedded domains, such things as the medical world or the transportation world or the smartphone app world. Then there was a series of attacks on performance. I realized pretty quickly that these devices tended to have performance issues of a variety of kinds, so I introduced that. The human user interface, I refined some of the work Whitaker had done in that because of things like the limited real estate of, say, the typical smartphone. Also, just basically the functionality of apps became an issue for many attacks. And then, interesting, while I was doing the work, not too many years back, particularly in the mobile space, nobody worried about security. And in the cell phone world, when they were just a cell phone, security wasn't a big issue either. But now, the embedded world, everybody's putting embedded systems on the network. In the smartphone world, there are viruses, there are user interface hacking attacks going on, and so the issue of security testing came into the forefront, and so I started doing research on that. It's a fast-moving area. The attacks that I have, I think, are strictly a beginning. Every time I read something, it seems like there's a new pattern emerging in there on the security world. So that one's very fast-moving and very scary for many of us working in the mobile and embedded space, by the way. And then finally, there are some generic attacks, such things as mind mapping, and a big area that I'm very much interested in these days, combinatorial testing. And there's some books and websites out on combinatorial testing, if that's a new name to you. Go ahead, next.
Could you shortly explain that for the audience,
so,
John?
Those are the general, pardon me?
The combinatorial testing, could you shortly explain that to the audience?
Jan.
The combinatorial testing, could you shortly explain
Sure.
that to the audience?
Yep. Combinatorial testing is a mathematically based approach to testing that uses a form of mathematics called combinatorials to take where you have large numbers of inputs, say like the number of hardware devices that you want to test in a mobile app and the number of operating systems that can be on those, with the number of apps that you might normally have to interface with your app. If you think about that, you might end up with 60,000 tests. Well, nobody can do 60,000 tests. Combinatorial mathematics offers a way to drop down from like 60, 70,000 tests down to 100 or 200 tests, something that could be done very quickly. So it's a form of mathematics that offers a rigorous approach to dealing with large numbers, to go from very large numbers down to reasonable numbers. And without getting into more detail, that's a thumbnail of combinatorial testing. Again, you can Google on that kind of stuff. So on this chart, and I'm not going to read all of these, I mentioned I had 33 attacks and 8 sub-attacks, and I gave you in the last chart kind of the generalized chapter areas. Here you see the attacks that I came up with by name and by number. And They're the kind of things that nobody would apply all of these attacks on a single device, mobile or embedded. You would use these kind of as a menu that you might have in a restaurant to pick one or two or three of these things depending upon, again, that risk analysis and the kind of exploratory test you're doing and the phase you're at. So you might start out with something like basic functionality checks down there, number 33, when you're in early prototype agile acceptance testing. And then later on move to something like the security testing areas under like attack 29. So that's how you would potentially use attacks. You wouldn't do them all, that's not what I'm saying, but you would pick and choose ones based upon the risks, the concerns that the team has with the particular mobile app or the embedded device you're testing. Go ahead, next chart. So we give you a large menu, large number of patterns on things. A little more specific detail now on one of these is out of the embedded world where we have what's known as digital to analog and analog to digital conversion problems where you're taking maybe a sensor information that's plugged into say your heart rate. I've seen some devices that do this. So it's a little heart rate monitor that you can put on your wrist. It talks to Bluetooth to your smartphone. So your heart and your body is an analog system. It goes from an analog signal to a digital signal into the computer smartphone that maybe does some kind of computation and then provides that information back to the user as an analog display, which is really a digital display, by the way, or maybe sends something to your doctor. So the taxonomy indicated that there were a lot of bug possibilities in this analog to digital and digital to analog world, A to D, D to A. And so I list a series of situations there. I'm not going to read all of these. It lists the impact and then some notes associated with that. So in the test pattern associated with that, a tester would come along, use this kind of information, say, yeah, gee, I might have loss of information where I go from an analog signal that has lots of information to a digital signal that's only got 16 bits. You could express more in 32 bits, but maybe I can't afford that performance processing. Is that a problem? Is that a bug? You would have to then do some analysis, do some testing to give that information and feedback to the developers that go, no, 16 bits isn't enough. We're losing kind of in the middle there, it says least significant bit error. We lost too much information. We need to go to 32 bits for that heart rate monitor to get things properly displayed. If you can do that early enough in the development cycle, that may save a lot of rework and or going out of business kinds of things. Go ahead, next slide. I know I'm running out of time, but we've answered some questions. So that's an example of kind of things that I'm talking about in here. And again, we do much longer tutorials on these things. I always like to frame things in the skills that I want testers to be developing. I know Jean Ann talked to some of this if anybody was in her session. I expanded just a little bit on what she did, and she took things from my book. She was one of the reviewers of it. You need the classic tester skills, certainly. But I also believe in the mobile embedded space, you need, as a tester, some exposure and knowledge of the product domain. Whether it's a mobile smartphone game app or an automobile app or a medical app, you need something for that domain. So to make you a better tester. And how do you go get that? Well, a lot of years of experience. We know some people come from the medical industry into the test world. Some people come from the gaming industry into the test world. Those are two different paths to get into becoming a tester and building up skills. Third bullet there, the hard sciences, math, physics, electronics, hardware, engineering, logical thinking processes. I came out of being a mathematician and have learned these other knowledges of domain and software testing. It's a never-ending thing to continue learning. And then the fourth one there is a very interesting one for me. There's an awful lot of soft science in software testing. Psychology, sociology, human factors, gaming, what makes a human happy, what's fun. Those are very difficult things to kind of know and understand, but for me as a tester, if I can have those things, makes me a better tester. I can do more practice on building skills. And probably the biggest one for me, and I hope a lot of the people that joined today are here because you are passionate testers, but be passionate about this field. Don't make this just a job, make it a career. Go ahead, next chart. So we're basically at the end here, a little bit of preaching there and the passion and having passion for things. Going out of this, I'd like you to go off and think. Again, you can email me and talk to me on these things. But do you know how your software fails? That may introduce some patterns for testing your software that I haven't mentioned here by name. Do you know what success and failure is in your domain? I mentioned games and having it be fun. That's a very subjective kind of thing. And then ask yourself where you can improve. What skills can you build? So ask yourself those questions, please. Next chart.
It's there.
Okay. So I always like to, say that I stand on the shoulders or backs of some very smart people and give credit for a lot of the ideas and thoughts that I have. People like James Whitaker, Elizabeth Hendrick, Lee Copeland, Brian Merrick, James Bach, Kem Kainer, and Gina N. Harrison, plus a lot of other teachers and people that I don't mention. If I cheated anybody, I apologize. I'd like to say thank you to everybody and people that are here. And I think we're done. The next couple of charts that are out there are just a list of the references for where a lot of this information come from. Again, I like to cite references and the fact that I do a lot of reading to build my skills and my practice. And with that, I'm done.
Thank you very much, Jon. I think for those of you that heard the church bells ringing, they're a little bit ahead here in Holland. I think we can pop in one short question, and then the rest of the questions will continue via email. I got a question from Sean, who did a seminar with us earlier on agile testing teams, and his idea is that he needed a different type of personality to function well in an agile team. How would it relate to some of the skills and the patterns you mentioned earlier? How do you find those people, maybe, or how do you build your teams?
Yeah, that's I'll say, somewhat difficult question, because I agree. I think a lot of people, when they move into Agile, struggle a little bit, because Agile, everybody in, say, for example, Scrum team, kind of everybody's responsible for everything.
Mm-hmm. Exactly.
And so, you have people that are developers and maybe somebody that's a business analyst or a systems person. I've been in places where we actually had a hardware person as part of the team, because we were doing something that was very hardware related on an embedded system. And we had somebody that was, I'll say, the test expert. And so I think as a tester, how we have to view that is, yeah, we need to expand our skill base a little bit, maybe into some of the diplomacy and psychology types of things, to be, I'll say, more flexible. And a lot of testers go, well, I don't want to write code. Well, you don't have to write the code that's deliverable, but Agile does a lot of automation of things, you can be writing code for the tests in something like Ruby or maybe testing scripting language, and you can use one of the patterns to help do that. I had one team where the testers were helping create some of the scripts that the developers used for testing their code and doing their test-driven development. The testers set some of the frameworks up for them, so it was much easier for them to do their test-driven development. So that's an example of where, yeah, the tester's skills need to expand a little bit, and I'll say be a little bit flexible with that agile environment. And you know, I'll say for me, a big part of agile is communication and talking and finding out, gee, what does the team need me to do with the skills that I have, and maybe bringing some of those patterns in. As I said, I've got developer level patterns that a tester can say, hey, we should be doing this as a pattern for this agile team.
Okay, thank you very much. I don't want to hold off the people here in Europe from their dinner and the East Coast people from their lunch, so I think we should stop it now. It was very, very interesting. Thanks a lot for joining us.
Thank you, everybody.
And your book is coming out now. You'll get information on the book in an email, and I'll put also information for where you can find the recording of the webinar in that email. We got a couple of questions we didn't manage to answer now, so we'll do those via email as well, right, John?
Yep, I'll be happy to answer those once I get them.
Okay, thanks, John. Thanks, everyone, for joining. Thanks, Amy, for helping with the slides, and hope to see you again soon. Bye-bye.